There are many different ways to run machine learning workloads, and many questions to go along with that. What can I run my workloads on? What are the options for libraries I can use to help with training and running those workloads? Let's say we're a research team training a brand new large language model. You could train a model on a CPU, but that could take a while. That's where we can introduce machine learning or ML accelerators. ML accelerators can be viewed as hardware that can run machine learning workloads by speeding up the computation. These can range from hardware specifically designed to run just machine learning workloads to hardware that helps us run parallel workloads more efficiently. There are a few types of ML accelerators that we can use. One type are tensor processing units or TPUs. TPUs are specialized hardware developed by Google specifically for machine learning workloads such as training a deep neural model. They are power efficient for these tasks and can also help to save on costs for larger workloads. For instance, Google has used them to train their latest Gemini model. TPUs, in general, are great if we want to only run ML workloads. What if we're working on developing this model for a robotics system and want that system that we are developing to be able to handle other workloads, such as simulation? This is where graphics processing units, or GPUs, can come in. GPUs, originally intended for computer graphics, work great for parallel computation. The advantage to GPUs in our case is that unlike TPUs, they are able to run additional types of workloads, such as the simulation workload that we wanted, in addition to ML workloads. But hardware can only run our workloads. We need a way to define what those workloads will look like. For creating a language model, there are several frameworks that we could consider turning to. One option we could consider is PyTorch, a popular Python machine learning framework that is great for modeling deep neural networks. It's got an established community with lots of resources that make it easy to learn about, with many established researchers already using it, perhaps even on your own team. And we can even use PyTorch with TPUs by using the PyTorch XLA library. Or maybe you're a team with deep technical expertise and are looking for a way to make it easier to parallelize your process and run it across different platforms. In that case, you might want to consider JAX, created by Google, for your workload. JAX is a library for performing array-oriented numerical calculations with built-in features for automatic parallelization and distributed arrays. It's designed to be modular so that it can be incorporated into frameworks that you already have or are creating. It supports running both TPUs and GPUs, providing flexibility for where you are able to run your workload. What if you're a team with little experience and are not sure where to get started? In that case, you might want to consider Keras 3, which provides an easy-to-work-with interface for getting started, but allows you to get more into detail later by providing different backends. You can start with Keras, and then maybe explore JAX or PyTorch later when the time comes. Check the description for links to try out these tools with our notebooks, or maybe even create your own on Google Colab.